The CLO for this lesson is that students will be able to identify, in writing, the parent functions using their graphs, tables, and meanings, as well as the following language. If then statements, parent function, constant, linear, quadratic, square root, cubic, cube root, and absolute value. In your own words, explain what you think you're going to learn how to do in this lesson. So the only vocabulary word that I'm going to define up front is parent function. So a parent function is a function within a function family that has no transformations. A parent function is basically the main one. So there's tons of different function family types, and each function family type has its own different shape. So it holds the shape of its family. So based on what type of function it is, it'll always make a certain shape. And the parent function is the one that has no transformations on it. So there's a lot of competencies in math. And remember, competency is what you have to prove you know how to do well enough in order to graduate. So one of our competencies is transformations of shapes and equations. So remember the transformations. I talked about this in the deep dive for the last lesson. But transformations are ways that you change something. So you can transform something by doing a lot of things. You could do things like you can move it up, down, left or right. You can also reflect it, which means to turn it over, or you can rotate it, which means to spin it. Remember the big word for move was to translate. So you can do these things to shapes or equations. Another transformation is to stretch something or to shrink it. So these are all the different types of transformations that you can do to shapes and equations. Because remember, equations, depending on which function family they belong to, will make a different shape because each family has its own shape on the graph. And so if when you graph something, it makes a shape, you can transform any shape, which means you can transform equations too, because equations make shapes when you graph them. So they want you to be able to do this to any type of shape or equation. Another competency that you're going to have to prove mastery on is to be able to go between representations for all function families. So by going between representations, I mean going from the situation to the graph, to the table, the equation, and back and forth between any of the two. So a lot of the times, in order to take equations and make a graph, you can do that by knowing the different transformations that are happening. So this unit is going to teach you how to graph all of the parent functions, no matter what transformations they have, and how to make their graph. And then how to go from the graph to the equation. And to do all of this, we're going to need tables. So the only one that's going to really be missing is situations from this unit, but you learn them in other units. So this is what we're going to be working on for the unit. To begin, we have to learn all the basic parent functions, like all the main ones. So let's learn them. The constant is the name of one type of equation. And basically the rules of a constant is that the equation is going to equal C. and C stands for a number. C equals any number. So the important part here is that for constants, there's no x to plug into. So like if I picked any number, for example, if I said y equals 5, because there's no x to plug into, if x is 1 and I go to where the graph is, the answer is 5. If x is 4 and I go over to the graph is, the y is 5. This graph ends up being a flat line where the answer to every x is up at 5. You see how the y is 5 for every single point? It's because the equation is that y equals 5. So if there's no x to plug into, it doesn't matter what x I try to plug in. The answer is whatever it's saying the equation equals. So if it equals 5, like on this one, even if x is -1, the answer is 5. If x is 0, the answer is 5. If x is 1, the answer is 5. No matter what the x is, the answer is that C, whatever it equals. So what does it do? The answer is always C. So if I had to graph this, let's say 2 is C right now. So I'm going to put a C by it. That means it'd be a flat line. Everywhere y is 2, pretend I can make a flat line. So the shape of constants is that they always make a flat line. The next one is a linear. And the rule of linears is that the biggest exponent is a 1. So what that means is that the equation is going to be that f of x is equaling x. Because the exponent on this x right now is just a 1 because there's no exponent on it. So other ones in the linear families can have numbers in front of that x. There can be things being added onto the x, and it's still linear. But the basic parent function is when it just equals x. So when you plug a number into that x, so for what it does, this one's the basic one. You just plug it in. And then you just end up doing whatever's around it because there's no special instructions for linears. So if I plug in -1 into this x, then the answer is just -1. If I plug in 0, the answer will be 0. And if I plug in 1, the answer will be 1. So if I graph those points, -1 means go backwards 1, and then -1 means go down 1. 0, 0 is right in the middle. And then the 1, 1 means go right 1 and up 1. And so those 3 points, and you'll connect them and make a shape. But which shape? Well, if I was to look at the line y equals x, zoom out, linears make straight lines, but they aren't flat, they're diagonal. They go side to side. They aren't flat, like a constant. So even if I added a number in front, still a straight diagonal line. Even if I subtract or add a number to it, it's still a straight line. So it just makes a straight line that's diagonal instead of flat. But this is the parent one, the main one, without being changed at all. So this shape is a straight line, and I'm going to mess it up. Ooh, pretend it's straight. All right, so the shape it should make is a straight line. It's not flat, it's diagonal, which just means not flat, going side to side, or across. So these are linears. In year 1, there's a whole unit about linear functions, how to graph them, what they look like in situations, what their equations are. So you should have learned all about linears before now. The next parent function is quadratics. We just learned all about quadratics. The most basic form of a quadratic before it's been changed at all is that when the equation equals x squared. So the rule for the quadratic is that the biggest exponent is a 2. So as you know, there can be other x's in here, like a normal x, and there could be just numbers. And it keeps it a quadratic as long as the biggest exponent is 2. So what a quadratic does whenever you have an exponent of 2 like this is it takes the number and multiplies it to itself. So if I were to take -2, try to square it, what that means is I have -2 being multiplied to -2 is because you take the number and you multiply it to itself. -2 times -2 becomes +4. So for this point, x is -2, so left 2. The answer is 4. +4 means up 4, and then I put a dot. For the next one, I put -1 into all these dots. -1 times -1 becomes +1. So to graph this point, when x is -1, y is +1. If I do this one, 0 squared means 0 times 0, which is 0. So there's a point at 0, 0. I plug in 1, 1 times 1 is 1. So the point is when x is 1, y is 1. And for the next one, when I plug in 2 times 2 becomes 4. So if I plot that point, when x is 2, y is 4. And then when I connect my points, I need to make sure for the shape that it makes what shape? Remember, quadratics make parabolas, which is either the U shape, if I can make it pretty, or the N shape. So in this case, it's opening upwards, so the parabola is going to make that U type of shape. And if I show you in Desmos, when I change it to x squared, it makes the U shape. Even if I add other x's or subtract numbers, it doesn't matter. Even if I put negative fractions in front, still makes the parabola shape. So as long as the biggest exponent is 2, it's in the quadratic family, and it makes this parabola shape. The next one's the square root family. So the square root family has a square root in it. So the most basic one is when the equation equals the square root of x. So remember, square root basically undoes x squared. Because it asks itself what number times itself twice is this number. So you remember if we wanted to, we could split apart the number under the square root into all prime numbers and say which one's under there twice, and then that's the answer. So if I tried to do the square root of -1, remember, what's the square root of -1? Remember, it's positive and negative I because it's imaginary. If we try to put it into Desmos, we'd say it's undefined. You cannot actually graph the square root of -1 on a graph because it's imaginary. So there's going to be nothing over here in the negative side of the graph. I can also do the square root of 0. In Desmos, the square root of 0 is 0 because 0 times 0 is 0. Which means there's a point at 0, 0. Square root of 1 is 1. Don't forget, it's also negative 1. However, when we graph it, we only graph the positive ones. The square root of 4, well, 4 breaks into 2 times 2. So the answer to the square root of 4 is just 2. And negative 2, but we're going to only graph the positive one. Actually, I'm going to quickly write in green the negative answers and graph them in green. So there's also negative 1 and negative 2 for these two. And then the square root of 9 is going to be 3 and negative 3, because 9 splits into 3 times 3. So in the one we're supposed to graph, it would go at, when x is 9, it's up 1, 2, 3. And then there's the other answer, the negative 1, 2, 3. So that when connected, this is the shape it makes. So if you look at x squared, which was like this, and its inverse, the square root, it's like the graph turns sideways. You see how it rotates? It rotates 90 degrees clockwise, and that you get this graph right here. That happens anytime two equations are inverses of each other. But remember, we don't like graphing the negative ones. So I'm going to take those away. This is the proper shape for the square root graph. If you tried graphing it, so how it makes that shape, where it starts slow and kind of curves up like that. So its shape, top half of sideways U. So that's the parent function for the square root graphs. The next one's called a cubic. And a cubic is where the biggest exponent is a 3. So there could be x squared in there, and it still won't be a quadratic anymore. Because if the biggest one's a 3, then it's considered a cubic. The parent function is x to the power of 3. What you do mathematically is you take a number and multiply it to itself 3 times. So if I was trying to do negative 2 cubed to the power of 3, that means negative 2 times negative 2 times negative 2 again. So a negative times a negative is positive. But then if I times it to another negative, it's back to being negative. And then 2 times 2 is 4, times 2 again is 8. For this one, if x is left 2, the y is down 8. So there's that point. It's 4, negative 1. Negative 1 times negative 1 is positive 1. Times negative 1 again becomes negative 1. So when x is left 1, y is down 1. If I were to plug in 0, 0 times 0 is 0 times 0 is 0. So there's a point at 0, 0. I plug in 1. That means 1 times 1 times 1, which is just 1. So there's a point here at 1, 1. And finally, if I plugged in 2, 2 times 2 is 4, times 2 again becomes 8. And so there is a point at when x is right 2, the y is up 8. So now I have to connect these points to make the right shape. So if I look over at Desmos so you can see the full graph, when I do x with an exponent of 3, this is the shape. See how it kind of right here curves up and curves down like this? It's kind of like a weird S almost. Almost. So the shape is sort of S-like. So I like to start in the middle and then curve up, and then start in the middle again and then curve down. And that's the best way I know how to make this shape. So if I come to my graph, I'm going to start in the middle and curve up, then also come to the middle and curve down. Well, the inverse of a x to the power of 3, what undoes that is a cubed root. So remember, a cubed root is the root symbol, but then there's a little 3 right here to signify that it's a cubed root. So what this says, what number can you multiply to itself 3 times? Because that's the answer. So I chose the x's, like for example, -2 times itself 3 times was -8, which means the cubed root of -8 is going to equal -2. The cubed root of -1 is -1. The cubed root 0 equals 0. The cubed root of 1 is 1. And the cubed root of 8 is 2, because 2 times 2 times 2 is 8. So if I were to put all my points, this time it's x that's -8. So I go left 8, and then the y is -2, so I go down 2. Then there's a point at -1, -1, 0, 0, 1, 1. And then when x is 8, the y is 2. So because this graph is the inverse of the cubic, it means it takes it and it turns it sideways. So I would call this shape a sideways sort of S. So when I start at the middle and go up, instead of shooting straight up like this, for this one, I go to the side up. And then on the other direction, it's to the side, but down. So it's the sideways version. So it goes like that, and then like that. So that's what it looks like up and down versus when it goes side to side. So this up and down is for the cubic, and then side to side is for the root, the cube root. The last parent function you have to learn in this unit, because yes, there are a lot more, but these are the ones we have to focus on for this unit. It's called absolute value. And you know it's an absolute value if it has this symbol in it. This symbol means absolute value. So the base of the equation, when f of x equals the absolute value of x. And what absolute value does to a number is it makes the final number positive. So whatever the final number in the absolute value ends up being once it's down to one number, it's going to turn it positive. So if you did some math and you ended up with the square root of -2, the answer will become +2. You do it and you plug in -1, the answer becomes, what do you think? +1. Plug in 0. +0 is just 0. Plug in 1, what do you think the answer is going to be? Stay +1 because it's already positive. But the answer ends up being positive no matter what's in there. So the answer to this one is 2. So I go ahead and plot my points. If x is -2, then y is going to be +2. So I'm going to go up 2, put a point. If x is -1, y is +1. There's 0, 0. There's 1, 1. And 2, 2. And the shape the absolute value makes is a V. You see that? So that's the shape of the absolute value. And pretend that looks more like a V, but that's that graph. So we're here with a shape, it's going to be a V. It could also be an upside down V. So it can go like that too. And that's absolute value. So in this unit, you're going to be asked to take functions that are in these families, these different families like absolute value or quadratic, and they're going to be transformed. So they're going to be slightly different than the parent function, which means their graph is going to look different. So in order to make the graph, you have to be able to know all the different transformations and apply them and then make your graph and make the right shape based on which family it's in. But in order to do that, you always have to make sure that you're plotting at least 3 points every single time before you make your graph to make sure it's a good graph. So you want 3 points and then you'll make the shape. So using if-then statements and these vocabulary words, explain what you learned in this lesson. One example might be, if the graph is a flat line, then the parent function is a constant. So explain everything you learned how to do in this lesson.